Lesson 7.0b, Introduction. So it is talking about the student practice. You guys have had time to look at these questions. What do we all know about a straight line? It has to add to 180 degrees. So we're going to take 180 and subtract this guy. How big did you get? 15 degrees. Okay, 15 degrees. Let's take a look at the next couple questions. Again, we've got another straight line, but this time we have variables. So what do I have to do when I've got variables? Okay, so this one, we all know it has to equal 180 for a straight line. So we're going to take this part and add it to this part to give us the 180. So with algebra, we need to add our like terms. So we're going to add all the x's together. So I have 2 of them here, 3 of them here. That gives me 5 x's. Then I need to add the digits that are alone, which are my constants. I have a positive 20, a negative 40, gives me negative 20. All equaling our magic 180. Now I can solve. I take my 20 over. By doing the opposite, I need to make it a 0 pair on the left so that it disappears. Now it's gone. Okay, this is old stuff. We did this back in Unit 4. Divide both sides now by 5. So this would add to 200. So I have x equals 200 divided by 5. X equals 40. But that does not solve for the angle. That only tells us what x is. The last step is to put that value where the x is in each one of those expressions. And that's going to tell us exactly how big that part is. So over here, if I go 2 times 40 plus 20, that's going to give me 80 plus 20. That tells me that this angle right here is exactly 100 degrees. Okay? Now, do I actually have to put the 40 in this one? No, you shouldn't have to. What should it add up to, we know? 180. So all we have to do is take 100 plus something equals 180. What should it be? 80. Good. Now we can check. 3 times 40 is 120. 120 minus 40 is 80. Okay? So it works either way. Further down. These ones can be kind of tricky. Let's take the easy one first. So we've got a triangle. Now, what about this triangle tells me that it's not isosceles? What tells me that these side lengths are not the same? How come you know? In the back. That's right. The angles at the bottom would have to be identical if that's an isosceles triangle. So even though it looks like one, this is not drawn to scale. It is not an isosceles, okay? Because the angles don't match. So how do I find the missing angle? All triangles, just like straight lines, add up to how big? 180. So I would take my 180 and subtract both of those. And how big is x? 70. Perfect. 70 degrees. Don't forget your degree symbol. Looking at the very bottom one, how can I find out this angle? How can I find out that angle? There's a rule we learned yesterday. How can we find out that angle? Right. It's opposite, being across from the angle. It's across an intersection. So this guy is going to be 45 degrees. It's going to match. Now, can I find out how big A is? Yeah. Yes. It forms a straight line with that 110. So I've got 110 plus something equals my 180 straight line. How big does A have to be? 70. Perfect. All right. Now we're back to triangles again. I've got a triangle right here. And we know triangles have to add up to how many degrees on the inside? 180. So to find B, we're going to take 180 and subtract the 70 and subtract the 45. That's going to give me B. So how big is B? B is 65 degrees. Excellent. Okay. Because C is across from him, what do we know about C then? It's also 65 degrees. Good. Because the ones that are across, okay, if they're across an X or a plus sign, they're always identical. Okay, check your work on those. We're going to move on. Moving on. Now we have a similar situation. We have a straight line here. So this number here and the A have to add to 180. So that guy's going to be 50. Now again, we have another triangle. We know triangles add to 180, so I can take 50 and the 72 and subtract them from 180, and I'm going to find B, and B is going to give me 58. Okay? And we know that opposites are identical, so C, who is below him, is also going to be 58 degrees. Okay? Check your work. Last question on this page. We've got one angle only. We can always find out how big the angles are if we know only one angle, because these guys are identical. The ones across. This guy's 75. And then we've got two straight lines. I've got a straight line going this way, where this 75 plus this number here have to add to 180. And I've got 75 over here has to add with this number to become 180. Okay? I've also got another straight line that I could go this way and do the exact same thing. Okay? So we're going to take 180 and minus our 75 and give us 105. So that guy's 105, and so is that guy, 105 degrees. Okay? Moving right along. Some of our similar, easy peasy questions. Straight line. What kind of angles do we call those two? What does X and 51 create? It creates a certain kind of angle. What would we call that angle when we have two or more that add to 180? Two or more add to 180. It's a special kind of angle. It's a special name. What do we give that name? So it's with an S. Sorry. Supplementary. Okay, they are supplementary if they add to 180. If they add to 90, they're complementary. Okay, so we're going to take again 180 minus 51. How big is that guy there? 129. Good. Over here, same rule. There's a straight line, has to add to 180. So I take 180 and subtract that 133. How big do you get? 47 all day long. 47 degrees. The degree symbols are missing, so please put them in. On the bottom, again, another supplementary angle. This time we have three of them that add to 180. So I know two of them. I'm going to take 180 and subtract both. And that's going to give me the missing angle. So how big is my missing angle? 68 degrees. Good. 68 degrees. Check your work. Another supplementary angle. Here we go. 180. So 180, subtract our 88, subtract our 44. That gives us X. So X is going to be equal to 48 degrees. Okay? What kind of angle do we have right here? Again, it's a 180. But if we only talked about this section, right here, what do they have to form? 90. And the reason I know that is because over here it says this one is 90. That box means it's a 90. Okay? That means the other half has to be 90 because we have to make, again, a straight line. Here's our straight line of 180. So this side here that I have colored in yellow is going to add to 90. So I'm going to take 90, subtract my 33, and that's going to give me X. So how big is X? 57. Good job. You guys are rocking this stuff. All right, let's look at a couple more examples. All right, a couple more triangle type examples. So only ones I can start with right now are these guys. I can start here with my supplementaries and with an opposite. So how big does C have to be being an opposite of 72? He'll be 72. Perfect. D and 113 must add to how big? 180. So we're going to take 180 and subtract the 113. I get my little piece of D here. It's like a piece of pie. How big is D? 47. Okay? Now we're back to having another triangle. So now I've got a triangle. 67. Is it 67? Oh, you're right. Absolutely, I wrote the wrong number. Thank you. 67. Perfect. Okay, I have another triangle here. Right there. And triangles will add to 180. So I'm going to find B by taking 180, minusing my 72, and minusing my 67. I'm going to get B. So how big is B? 41. And if B is 41, how big is A? 41. Perfect. So what two rules are being used all the time? What do you notice? What two rules? We have two rules that are being used all the time here in the back. Straight lines add to 180. Perfect. Opposites are identical. Beautiful. Exactly. That's one of the ones I was going for. There's one more. Straight lines add to 180. Opposites are identical. And there's one more. I have them outlined in color. Right. The triangles also equal 180, okay? So there's lots of things we're doing over and over and over again, repetitively. So knowing opposites, how big is Z? 110. Or sorry, 101. Pardon me, I mixed up my numbers there. 101. Now, because I know there's another straight line going that way, or the other way, this way's fine too, how much does this Y and X have to become? 79. Good. Because they have to add to 180, and then the opposite will be the same. These guys will match. Okay? 180 degrees make a triangle. So I'm going to take 180, minusing 63, minusing 57. How big is X? 60 degrees. Perfect. Okay? Now again, we knew it was not an equilateral. It looks like every side is the same. Again, it's not drawn to scale. But what tells us that it has no sides the same? Something's telling us it has no sides the same. The angles are different. Absolutely, these are different. So, what if one of them, just for giggles, what if one of them was a 60-degree angle and it asked you to find the others? Well, actually, I'm going to do this. What if two of them are 60? Then the other one has to be 60. How do you know this one has to be 60?
60 plus 60 is 140, and it requires another 60.
Absolutely. 60 and 60 give us the 120. These two then will give us 180. Okay? Now, that'll mean these are the same size. When you've got two of the angles that are going to match. Those two match as a 60. The other one has to be a 60. If the bottom two match that are other numbers than 60, for example, if I go 57 and 57, if those two match, but they're not a 60, what does it tell you about that triangle? It's a what? Isosceles. Beautiful. When you have the two bottom ones that match, those are the same size. It's an isosceles then. Okay? And that means you take, again, 180 to find that one. Okay, last question. Let's see how this big one went. This one's using every single one of those rules. So, we can find B. How big is B? How big is B? 35. Good. Okay, knowing opposites then, how big is G? 35. Good. Also knowing opposites, how big is H? 145. Perfect. Now, can I find letter C? Yes, because these make a straight line. So I can take 180 minus this one and minus this one. I'm going to get C left over. So 180 subtract 77, subtract 33. How big is letter C? 70 degrees. Good. He's 70. So now I know he's 70. I have a triangle right here. How big is A going to be? 180 minus 70 minus 35. That's going to give me angle A. So how big is angle A? 75. Which other one has to be identical to him? K, because he's opposite. Okay, let's find now. If we know this guy's 70, these guys add to a straight line right there. So how big is D? I've got 33 and 70. I need to find D. 77. Good work. Okay? Those three add to 180 and make a straight line. Okay, now do I have all the opposites for me to find E and F? Yes, I do. So how big is F? 70. How big is E? 33. Wonderful. Absolutely. Who got absolutely everything right so far? Nice work, everybody. Nice work. Okay, that concludes our practice section. No, I can go back. Oh, okay, let's go back. We have one question left. We forgot about I and J. Whoa, my goodness. We forgot about I and J. So I and J, how do we find those ones?
Well,
Is it not
just 75 minus 180.
That's right, they make a straight line here. So 180 subtract that 75 will give me I and J. So how big is I and J? 105. Good work, you guys. Make sure I get that right. Excellent. Now we are done with our angle properties and practice section.
I just want to get